Okay, so yeah, we have not learned any other language other than Scratch yet. We're ready to broaden our horizons. Let's learn about Python today. So a lot of stuff to teach you. The first step to learning Python is actually installing it on your computers. And something really nice about these computers in this room, if you didn't bring your own laptop, is you can technically download and install whatever program you want on this computer. Just when it restarts, it's going to have a different program, or it's going to be back to square one again. It's going to go away. But I would like to give you practice with installing Python, because that's what you're going to do to do your assignments. So let's go to python.org/downloads, or just search for Python on Google, and let's install it together. Python, download, something like that. And just go to download Python, python.org/downloads, and you're just going to click download. Download Python, whatever it is. 3.10, you do not want Python 2, that is old. Nobody wants that one anymore. So save it, double click it, and let's install it together. You should be able to install it on these machines if you would like, and then it'll be there until somebody restarts them. And so I'll just click default installation, install now. If you have like a Chromebook or something that cannot install Python, there are websites you can search for, just like, I would like to program in Python online, please. There's this website, there's Replit. Those should come up when you search, and I can help you find one if you're unable to install Python on your own computer, but most of you should have a Windows or a Mac computer to install this on. I can also help you check out a laptop from the library. They will give you a Windows computer, I think. So yeah, let's wait for this to install, because then I have to open it to teach it to you. Were we all able to find the download link? And are you actually able to install it on these computers still? They are new this semester, but I think the rules are the same. It's thinking about finishing. Any day now. And then it's going to be installed, and it'll appear in the Start menu or in your Applications folder if you're on a Mac. And you might think to be like, all right, I'm going to go scroll down to or search for Python, but that's not what you want to click. You don't want to click Python 3.10. You want to click idle. So you should search for the word idle instead, really. Idle. That was the default one that came up for me anyway, but that's what you really want. You want idle. Okay, so click that one once it's done installing and open it up. Okay, so install it, open up idle, and it should look like this. Is anyone having any trouble getting this working? Maybe it's still installing for you, but do we all understand the process? Because this is Python. Look at it, so pretty. Nothing like Scratch, right? No beautiful cats anywhere. Just blankness, text everywhere. 3 lines, or 3 greater than signs, and now I can start typing stuff. But that's Python right now. Question? Mm-hmm. Like if I were to actually click on the Python one? Yeah. That opens up the same thing, but it doesn't let you make your own Python files. Like there's no file, new file, there's no run whatever's open right now. This is the graphical window that we want for this class. This would just be, I want to type a single line of Python code, not for us today. Yeah. No, that's just something called the REPL. So let me show you what that means. We want idle open for sure. So yeah, once you open up idle, it plops you into this thing called the REPL, which stands for read, evaluate, print, loop. So read, evaluate, print, and then it just repeatedly does that, so we call it a loop. So first it reads the thing that you typed, you hit enter, it evaluates it, it executes that Python code that you typed, and then it prints out the answer, and it just repeatedly does that. So it's a read, evaluate, print loop. So this window, you can type a single line of Python code, and it will run that single line for us. We're eventually going to graduate from single lines to multiple lines today, so look forward to that. But yeah, we can type single lines of Python code, and I'll show you that in a second. But I should first tell you what in the world is Python, right? It's a programming language like Scratch, but there's no clicking involved. It's just a bunch of typing, right? It is not a graphical programming language. It's a text-based programming language. So the code that you write is not a bunch of blocks that you put together. It's not like block 1, and then that fits in ever so nicely with block 2. No, now in Python, it's just, all right, you write a line of code, line 1, in text form. Then below that, you put line 2, and they get executed in order from top to bottom. Okay, it's just lines of text now, right? If you want two things to happen one after the other, you just put them one after the other. You press enter, make a new line. Okay, so that's a bit weird. It'll take getting used to. And then, like, I'm going to have to teach you how to, like, build up bigger things, right? Because remember your if-else blocks and all that. If-else. How in the world do you put stuff inside of other things in Python? We'll get there. Don't worry, but just think sequentially right now. That's what we're going to do today. Yeah, so you can, well, how should I say this? In Scratch, you can't make a program that doesn't make sense, right? You can press the green arrow and it'll work and it'll start running. You cannot write a bad program. You can write a bad Python program. You could speak Python incorrectly and it won't even try to run it. So I'll show you that. But every time you type a valid line of Python code, it has a specific meaning that it'll teach you. And yeah, because it's just text, you can make a mistake. It's not just graphical. Instead of if, maybe you type like, I don't know, all right, you type of or something, like you miss the I character or something. And that won't even run, all right? So Python will complain if you make errors, and I'll show you some of those errors, okay? And inside of Python, when we run Python code, it's what's called interpreted. Python is interpreting your code, translating it from the English that looks like, translating it from the code that looks like English into stuff that it can do on your computer's processor. So are we ready to learn some simple lines of Python code? Well, let's do it. So let's go to our REPL, and let me just show you how to do simple math, all right? So I can type 2. That is a valid line of Python code. If I hit enter, it's going to read it, evaluate it, and print the answer. Oh, yeah, 2 is 2. Cool. 2 plus 2. Oh, that's 4. You can put as much white space as you want. I could say 2 space plus space 2. Still happy. Press enter, it's 4. So it reads it, evaluates it, prints out the answer. Not too bad. So you can do some quick math in Python if you need to. Like 1 over 2, that's division. 0.5, that makes sense. Star is for multiplication. Okay, so 4 times 5, that's 20. It all works out. 3.14 times 5, it all is fine. That's a little bit off, but we'll get into that in a future lecture. But it all works. That's simple math. Those are all technically valid lines of Python code, just asking it to do math for you, okay? This operator is called modulo. I told you this before, but now we can actually use it. That gets the remainder of things. So if I say x modulo y, that % character, that'll get the remainder after dividing x by y. After dividing x by y. So, for example, I can check that the number 42 is even by telling Python, hey, please divide 42 by 2 and show me the remainder, 42 mod 2, 42 modulo 2. There's nothing left over. So 2 went in cleanly. It was an even number. 41 modulo 2 is 1. There's 1 left over. Okay? So that's one thing you can do with modulus. Check if a number is odd or even. So that is that operator. And of course you have plus and minus. Does that make enough sense? Just like a calculator at this point. You good with that? No? Letting it work? 2 stars, you might think it was like the caret character, but no. It's 2 stars for to the power of. So if I want to calculate what is 2 to the 3rd power, 2 star 3, that's 8. Okay? That's how you do that. So that's just a bunch of simple operations on numbers. They can include decimal places. Totally fine. Not a big deal. Okay? So if we're okay with that, let's make it a little bit fancier. All right. I want to talk to you about a concept that really wasn't apparent when we did Scratch. Let's talk about types. All right. You can ask Python for the type of something by saying the word type, putting some parentheses, and then in the middle of those parentheses, putting the thing you want to know the type of. So like I can ask Python, hey, what's the type of 5? That is an int. Okay. Hey Python, what is the type of 3.14? That's actually a different kind of number type. It's called float. So let me tell you the difference. I want you to think of types as little clouds. All right? You can only put certain things within the clouds. So here's the int cloud. It holds whole numbers only. 0, 42, negative 42, 1, 2, 3. All those things are integers. All right? So we say int for short, and that is the type of those numbers as far as Python is concerned. Okay? Those are whole numbers only. Floats, though, are numbers with a decimal point. If you want to use those, they're different. The float type holds things like, I don't know, negative 23.145. It holds 3.14. It technically also holds whole numbers if you want to put them like that. You can make 2.0. That's a float rather than an int. Okay? Different types do different things in Python. That's why I'm spending time on this. You can also put stuff between characters, or put stuff between quotes, characters between quotes. I can say hello between 2 quotes. Hit enter. And it puts them between 1 quote. Interesting. So the type of quotes hello is a stir. Stir stands for string, right? It's like, I don't know, a string of beads that are characters on like a friendship bracelet or something. That's how I think of it. Not sure why it's called string. Maybe we can go to Wikipedia. But anything between quotes, hello, double or single quotes, it doesn't matter to Python. So double quotes hello is the same as single quotes hello. Hi, Mom. Those are all strings as far as Python cares. Okay? And the type dictates what you can do with the thing. All right? So if I have a stir, like if I have hello, that's a stir. Double quotes or single quotes, it doesn't matter. They're both the same. Python prefers single quotes. It's spitting it back out to me as single quotes. But plus and star work on stirs. They work on strings. Watch. Hello plus hello. That's plus. That's for strings, right? That makes sense. Something to watch out for, though. What's the type of this? Is that big enough for us to see? No, there. Boop. It's a stir still. So what's the string 42 plus the string 12? That's 4212, the string. You see the difference? For strings, it's just a bunch of characters. But for ints, it's actual number stuff. The difference between that and 42 plus 12. Interesting. So the types dictate what you can do. You can also multiply strings. You can multiply strings by a number. It can be like hi times 3. And that makes hi. Makes sense to want to do that, right? So, yeah. A string times an int is completely different from an int times an int. I can say 12 times 2, and I can say the string 12 times 2, and those are not the same, right? The answer for this one was an int. The answer for this one was a stir. Are there any questions about that? So that's the cloud. The clouds of different types. And they tell you what you can do. Some things are not allowed. Here's an example of an error. It makes no sense to multiply a string by a string. So you get some very ugly red lines when you try to do something wrong, but this is me speaking Python incorrectly. Can't multiply a sequence by non-int of type stir. With enough practice, you can unravel what that means. I was looking for an int. You gave me a stir there for the second thing. Can't do that. Okay? Any questions about this? These types? If we're good, I have a question for you. So try to get together into your peer instruction group, say hi to one another, and I'll give you a couple minutes to try to do this. I would like you to create the string hello, 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 all the way for 42 hellos. Okay, so there are 42 hellos in this example. I'd like you to make that string. And they're all separated by a space, except for the last one. So how can you make hello, space, hello, all the way for 42 hellos, but without a space at the end? See if you can figure that out together. So I'll give you a few minutes to try it. Please ask me if you have any questions about it. How would you do it? Maybe try a simple one, like 5 hellos, so that you can actually count to make sure it's working. Because it'll be the same process. Oh, you having trouble? It'll take like 2 minutes to try it out. You don't have to write it down anywhere. Just see if you can get it working. Things in programming, there's a million different ways to get this. There's one way that I would think of, I would say. The easiest way. Couple more seconds on my timer. All right. That is my timer. Was that enough time? Did we all get it? We're still struggling a little bit. So let's think about it for just like, I don't know, hello. How about hello 3 times? The way that almost works, right, is hello space times 3, right? But that's got that ugly space there at the end. That's not what we want. But for every other one of those, that's what we want, right? So I think, as good as I can think, this is how I would do it. I would split it up into this and then this. I think this last hello is special, right? It doesn't have a space after it. So can we make this smaller, hello space, Sure we can. That's just hello space times 2, right? And then we can definitely make hello by itself. That's just hello. How do we put them together? Plus hello. There you go. Times 2 plus hello. That makes 3 hellos without a space at the end. Is that what we got? Nice. And so if we want 42 of them, let's just make 41 hello spaces and then put that ending hello at the end. Okay? You may have already noticed that you can use parentheses. Maybe you think more logically this way. But the order of operations technically means nothing different if you put the parentheses or if you don't. Okay? Any questions about this question? All right. So, if we're still good, let's move on to longer programs, right? We've only written single lines at a time right now. That's no fun. You can't really do much with that. Let's go beyond the REPL, all right? Let's make Python programs. And so every Python program is just a text file, because all Python is. Python code is just a bunch of text. You customarily use the .py extension for a Python program, and idle's just going to magically put it there for you anyway. But you call your program program.py or whatever you want to put here. Give it a nice name. Okay, so all Python programs end in .py. That's their extension. All right. So yeah, Python programs, they consist of a bunch of lines of Python statements. We've been writing a bunch of statements. That's the technical term for all those lines that we typed into the REPL. They're called statements. And just like in Scratch, if we have a bunch of them in a file somewhere, they'll run one after the other in sequential order. Okay? So let's make a Python program that prints something to the screen, and it uses something called the print function. Okay? So I'll talk about the general term in just a second after I make this program, but I told you for Scratch, like customarily when you're first learning a language, you have to teach it to talk to you, so we're going to have it say hello world to us first. But this is what we're going to put in our file. We're going to say print, and then a string, surrounded by parentheses. And so if I hit enter, that's really nothing different than just putting hello and hitting enter, because Python's REPL automatically prints for us, right? It does the P. The P is already in REPL. If you make your own programs, the P is not automatically there, so we have to tell it whenever we want it to print stuff. You have to wrap it in this print function, we say. Okay? So what this line does, if I put it here, print, and then I put a string, hello, it's what's called calling the print function. So print is the name of the function, name of the func, and then the one thing that I want to print, I put between parentheses, and it's called the argument to the function. It's like you're yelling at print, hey, please do this thing for me, you're arguing with it. So there's one argument to the print function, to the print func. Okay? And so let's make a program now. I can go in idle to file new file, and then it just gives me a blank slate. And I'm going to save this somewhere immediately. I'll put it in our code from class folder. That's on the desktop. This one. What lecture are we? Lecture 13. Okay. Boop. So I'll call this, I don't know, what did I call it last time? Just hello world.py, probably. Hello world. Sorry, this is so zoomed out. That's just the default Windows stuff. But you can see that the type is automatically .py. It's just going to do that for me automatically. So now I've saved a blank file called helloworld.py. And inside of it, I'll put one Python statement, print hello, comma, space, world, exclamation point. Okay, that's my one file, and I got to save it. Now it's saved. And I can tell Python to run all the code in this file with the run menu. I go to run module, or I press F5. So it brings it over back here, and it starts running the entire program. There's the program, hello world. I can rerun it. All it does is it has one line, and it prints hello world. Okay? I'm calling the print function to do that. What questions do we have about that? That's very different from Scratch, right? There's no green flag anymore to click. Are we good with that? So print hello world. Now, in general, here's what happens when you have a function. You call it. You say, hey, I have a function. Here's its name. And let's see, how do I want to do this? Yeah. Here's a function. Here's its name, so like print. And then between parentheses, you put as many things as that function needs to run. Print just needs one thing. What's the one thing you want to print? Please put it between the parentheses. That's your first argument. But there can be optionally many arguments, and they all go through the syntax. And they all use commas to separate each argument if there's multiple. Okay? Some functions don't have any arguments at all, like, I don't know, maybe you have a function f. You just call it like that with open parenthesis, close parenthesis, okay? And so that's the function. We say that we're calling it with arguments, okay? It's like we're yelling at it, asking it to do something for us. And then optionally, we can save the result somewhere. And I'll tell you what this syntax means in just a couple slides. But some functions give back an answer. Print just does something for us, just prints to the screen, right? Some functions, like, I don't know, if you have like a square root function, it gives back the square root of a number. You can save it away somewhere. This is how you make a variable in Python. I'll go into that in depth on the next slide, though. But all we did was we called print with a single argument, open parenthesis, close parenthesis. Okay? That is the start of a program. You can have comments in Python just like we had comments in Scratch. Little notes for ourselves, not actual pieces of code. So you can have a single line comment. Those begin with a number sign. So if I make a number sign, everything after that on the same line is not Python code. Python's not going to look at it. It's just for us, the programmers, to leave ourselves notes. So this is a comment. It's not Python code. All right? Everything after the number sign is a comment. All right? So technically, that means I can have Python code, and then after it, on the same line, I can put a comment. It doesn't worry about things before the number sign. So this, I'd be like, to remind myself, hey, this prints hello world. Something silly like that. Okay? And if I rerun the program, nothing changes because I didn't add any actual new Python code. I just added notes for myself, comments. If you want a multi-line comment, you want to write a long thing, and you don't want to have to keep putting a number sign at the start of every line, you can use 3 quotes, either 3 single quotes or 3 double quotes, and they need to be closed off. So if you put 3 single quotes, that starts the multi-line comment. You also have to end it with matching 3 quotes, all right? So this is a multi-line space by space comment. You can have as much as you want in between these 3 quotes. So you can type a long book of notes for yourself, and it's all just one big comment that Python doesn't care about. So again, same program, nothing changes. Any questions about comments? There's no more right-clicking anymore. No more right-clicks and pictures of sticky notes. So yeah, that is our first Python program. Yay. Next thing I want to talk about is variables, because things get kind of unwieldy if you have to keep typing stuff. So you can have variables in Python, and they can hold whatever you want. You can name variables in Python to hold values, and you can call your variables any name under the sun as long as you follow these rules, right? Variable names cannot have spaces in them or special characters. Here is what you can use inside of a variable name. To make a variable, it better start with an underscore, a lowercase character, or a capital character, and then after that, you can put more of those and then also digits. All right, so here are some valid variable names. So x is a valid variable name. Underscore underscore x underscore underscore is a valid variable name. Underscore blah 42 is a valid variable name. But the variable 42 blah is invalid. Cannot have that in Python. It's got to start with one of these. Okay? To put something into a variable, you use what's called an assignment statement. And that is where you write the variable name and then an equals sign. And then to the right of the equal sign, you put something that will eventually become a value, and that thing gets placed into the variable. Okay? So I can say x equals 42, and that'll make a variable called x and put 42 inside of it. Okay? Just like we know and love. So let me show you that. I'll make a new file called vars.py, maybe. I'll save it. Really? How about if I save it? How about if I make a new file from this one? Then maybe it'll remember the folder that I put. Yeah, much better. Vars.py. So for this one, I can say x equals 42, right? That puts 42 into a box called x, and now I can print x, right? Whatever's there, please get it for me. If I run this program, it's going to print 42. Does that make sense to us? All the stuff that we know how to do in Scratch, just now in text form. Here's a fun one. What do you think this line does? x equals x plus 1. Yeah, maybe it's an error. Like, that doesn't make sense. At least as far as math is concerned, that it should never be possible. Like, why would you have a variable that changes its value? But in Python, that's totally fine. X equals x plus 1. Print x again. Save, run module. It made it 43. That's weird. So that line took x, what it was, and made it 43. And the trick is, the reason this makes sense and works is because the right-hand side of your assignment statement gets executed first. And so that's why it's not like a contradiction or anything. The right-hand side, RHS, gets executed first. Okay? And then placed into the variable you put on the left there. Okay? That's why it makes it 43. Interesting, interesting. So that's variables. Are you still good? Let's get more complicated then. We have yet to ask the user something. Have them type something and get it, right? So in Python, there is an input function that does that. You can say input. If only I could spell input. And it takes an argument. The argument is the prompt that the user sees when Python is trying to get the value that you're asking for. So like input, enter your name. And they're going to type right after your prompt, so it's nice to put like a little colon and a space so they have room to start typing. But that is an input function. It takes an argument, that's the prompt to ask the user, and it gives back the result that is the user's response. So if I do this on the REPL, input, enter your name, colon space, Python says enter your name, like prints it, and then it waits on that line for me to type stuff, Lawton, and hit enter. And then its result is whatever I typed. See that? This is the result. It's printing back the result after executing it, right? So input gave back the string Lawton. It gives back that result. That was your response, and it's always a str. It's always a string. Remember that. I'll underline that. Even if the user types a number. All right? So if I say input, enter a number, colon space, enter a number, and if I type 42, it's going to give me back the string 42, not the number 42. So if I want to do number stuff, I better convert this. I'll show you that in a second. Are we good with that? That's all about input. So, yeah. And then we can save away that input into a variable. It's like whatever this gives back, whatever the user types, put that into a variable called resp or something for response. It'll get placed like that. Okay, so let's make a new program. I'll call it, oh gosh, getting underscore input.py. And here's me doing that. I can say resp equals whatever the result of calling input gives back. So input be like enter your name, colon space. And that will get the input. So assuming I type my name, that will make a variable called resp that holds the string with my name in it, or your name, whatever you type. So after that line completes, resp will hold Lawton. I can say resp, I can have it be printed out. It will hold my name, all right? So I can print the type of resp, right? That's one thing I can do if I run this. Just to confirm that it's a str, right? Yes, it's a str, then the program's over. I can greet myself. I can print out hi and then me, right? Print hi, comma, space, plus resp, because that's how you add strings, right? Plus exclamation point. And so it's greeting me now if I rerun this. Enter your name, Lawton, that goes in the resp variable, it's a str, and then I print out hi, comma, space, Lawton from this line. Any questions about that? Does that make sense still? Now we're doing fancy stuff. Now we have multiple lines in our programs. Woohoo. We can also ask the user for their number, a number. So I can say like num equals input. Enter your favorite number, colon space. Still, num, print type num, that's still a str, right? So this isn't going to work. It's not going to do number stuff. Favorite number 42, that is a str still. Num is set to the string 42. That's no fun. So if you want to do number stuff with your response from your user, you can convert it to a number by calling the type as a function. Just be like, make an int out of resp, make an int out of num, make a float out of num if you know it has a decimal place in it. One or the other, okay? So I can do this. Boop. I can say num as an int equals, call int like a function. Now this will make it an integer, right? So num is only a str. We must convert it to an int, okay? And now I can print stuff like num as int times 2 and have it actually make it 82. That converts it. Or sorry, 84. Because if I made this num times 2 and I didn't convert it, watch what would happen. It's multiplication on strings now. I get 42, 42, 42, 42. And it's the string still, right? So if you want to do number stuff and you have a string, you better convert it. Convert it like this, then use this. That's the real number that you can do number things with. The types really matter in Python. Scratch did a lot of work for us. It saw that if it was a number, maybe we should convert that to a number for you. We got to do that ourselves in Python. Okay? Any questions about this? Are we still good? Okay. A lot of the time, you want to print a bunch of stuff out in one call to print, and it gets a bit unwieldy to put put plus signs all over the place. You can do better than that. The print function can take as many arguments as you would like to give it, which is nice. And what it will do when you give it multiple arguments separated by commas is it will print those things out space separated. Print arg1, then a space, then arg2, then a space, then arg3. Okay? If you don't like the spaces, then you're forced to use the plus. But here's another way that I could do that line. It's not going to be exact, though. I can say print hi, comma. It's going to put the space in there for me, so I don't need to add the space into the string. Then comma resp, then comma exclamation point. Okay? That's another way to do it. So print can take as many args as you want. It space separates them when it outputs. So if I enter my name, Lawton, here's the first way. Here's the second way. Hi, comma, space, Lawton, space, exclamation point. So maybe if you were outputting French, this would have worked. But it looks a bit weird for an English sentence. So it's automatically putting spaces around those different arguments. Okay, so that's another way that you can call print. One day you might want to print a lot of space-separated things. You don't have to put plus comma space all over the place. Print will do that for you. Okay? Yeah. Are we good to keep going? Because I've only shown you one function right now, or two. I've shown you print and input. There are many fancier ones. I'll show you a couple more if we're comfortable with these right now. Type is also a function, I guess. You can use a type as a function as well. So technically I've taught you a few. But it's all about getting stuff from the user and putting stuff on the screen for the most part. Some conversion. How about we do math? That's the last thing that I want to show you. So let's talk about the math library. And Python, because it's such a large language, it has a lot of stuff. It has different things called libraries, where you can do math stuff. You can do graphical stuff, do complex number stuff. They're all different things called libraries built into Python. That's the metaphor You can think of a library as a bunch of code that somebody else wrote for you that you can just go look up and use for yourself. Okay, so a library in computer science it's a bunch of pre-written code, like print inputs. Those are all pre-written pieces that are just by default available to you in Python. Pre-written code that you can use inside of your programs. Okay, and so one library that's very useful is called the math library. And you can search for Python math or something, and it will show you the documentation page for that library. Python math, it's going to be the first link. It's called math, all lowercase, and it holds a bunch of functions that have to do with math stuff, like absolute value, like, let's see, some other ones that we can understand. E to the something, logarithm, log base 2, log base 10. I guess this one is the natural logarithm. Take something to the power of something else. POW is what it's called. Get the square root of a number. Get the inverse cosine sine. Get the normal sine cosine. All those things, they exist in the math library, and I think you can imagine how hard it would be to program that yourself, right? Do some kind of infinite series approximation thing. That's what they're doing for you, okay? So we can thank the implementers of Python for giving us all these nice functions for free that we can use just by including, or the term in Python is importing, the math library, all right? So to use the math library, we must import it. So at the very top, or before we try to use a function defined in that library, we have to say import math. That's just a Python line by itself. It's just saying, hey, Python, please make these functions from the math library available for me from now on. Okay, that's what that line does. Makes math lib functions available to use. And inside of a library, you can define a bunch of functions like square root, like sine. You can also define variables. So the math library has also defined some nice variables for us that we don't have to go and compute ourselves, like pi. I assume they also have e somewhere. Math.pi. There it is. Got some constants at the bottom. So you got pi, e, tau, infinity, if you need that. So that you don't have to like write some fancy formula yourself to create this. It's just, I can say pi, I can say e. Okay? One other thing that when you use a library you have to always remember to do is if this thing that you're asking for belongs to the library, like it's maths pi, it's maths square root function, you have to prefix all those things with a math dot, the name of the library and then a dot, all right? It's always the name of the library you just imported, libname dot, the thing that's inside of the library that you need, that you're trying to use. Thing inside. Okay. So, yeah, let me show you some of this mathy stuff. So I can say import math, maybe at the top of the program, and then I have math.pi to use. I have math.square root to use, math.sine, all that stuff. Okay. So I would like to make a new file. And what should I call this one? Let's just call it mathstuff.py. One thing you cannot do, and I should put on this slide, all caps, never make a file with the same name as a library. So do not save your file called math.py right now. Otherwise, it will not be able to find the math library, because the math library is in a special place and it's also called math.py. That's a secret. Okay, so never make a file with the same name as a library. That will bite you one day, and it has bitten me so many times. So I just remembered it now. So I'm going to call it math stuff. Definitely not math.py. All right? Then I'll save it. Okay, so if I say import math, now I have the math library at my fingertips. I can say whatever I want. So now we are allowed to use all the math library functions. You just got to prefix them with math dot, right? That's all you really got to do. So, I don't know. What's a good example? Let's calculate the area of a circle, right? Let's calculate the area of a circle with radius, I don't know, 4.5. So what's the formula for that? How do I calculate the area of a 4.5 radius circle? What do I need to do? Like, what would I type into a calculator? Pi's involved, right? Pi r squared, isn't it? So I can use variables to simplify all this. It's pi r squared, right? Pi r squared. So I'll use Python syntax. Pi times r squared kind of thing. Right? So I'll save the radius. Let's make that a variable. Radius equals 4.5. And then I can make another variable to hold the area. Area equals pi times the radius squared, right? And so I have pi in the math library. I can say math.pi. Area equals math.pi times the radius squared, radius, star 2, right? That's the squaring operation. That's the exponent operator. That takes something to the power of something else. So now, inside of the area variable, I have the area of that circle. Print area. So now if I run this, apparently the area of a 4.5 radius circle is 63 point some stuff. 63.6. Okay? Does that make sense what I just did? Any questions about that? Using the math library. What else do we got? What do I want to show you next? Let's do square root. So square root is a function that takes a single number and calculates its square root. Whee. Boop, square root of x. So it takes one argument, the thing you want the square root of. So let's calculate the square root of, I don't know, some number that the user types. So let's get that number, right, from the user. Input, enter a number, colon space. Now I've got it, and I want to calculate the square root of the number. Num, what type is it right now? Is it something I can call square root on? What did I have to do all these times in getting input? By default, that type, whatever I get back from input, that's a stir. Right? So I can't use num right now. I can't give that to square root yet. I better make it a number. All right? And the user can type any number, so maybe including decimal places. So let's make that number a floating point number, or a float. Num as float equals, call float on num. All right, so now this variable holds the actual number representation of that string, and I can print out the square root of that number. So print math.square root of num as float. So I am calling a function with the result of calling a function. It's kind of cool. I'll get replaced with whatever the square root of that is, and I can print it back out. Enter a number, I don't know, 2.0. That's the square root of 2, that looks about right. Rerun it. 16.25, it's pretty close to 4, right? That's the square root. Does this code make sense? Just doing everything in order. Function calls get replaced with their the values that they produce. If they do produce something, like square root produces an answer, it gives it to print. And then finally, I can do sine. Let's take the sine of that value that the user types, so sine of num. All right, we're going to say math.sine of the number that the user gave us. Again, we got to use the actual number form, so let's call it with num as float. And then we can print that. Be like, let's print it in a fancy way too. Let's be like, print the sine of, and then we can give the number. num as float. Technically, we'd also give num here, since it's just something we're printing. We can say is, and then this will automatically put a space for us, right, in between all these arguments. Sign of num. That's pretty cool. So there is a complete program that I will try and show you with the output. There we go. So enter a number, 3.14. The sign of 3.14 is pretty close to 0. Okay? 0 with 2 digits of precision. Okay? So that's calculating the sign of that number, storing it into this variable, and then we're printing out that variable with some other stuff, space-separated stuff. Okay? So yeah, I think that was all the fancy programs that I wanted to show you today. Are we still good? Do all of these things make sense? Because the last thing I want you to do is try this yourself. We get to try it ourselves. So here is my question for you. All right. Write a program that takes two numbers, a and b, from the user and computes the square root of a squared plus b squared. So pretend that the user really wants to know the hypotenuse of a triangle right now, and maybe they type 3 and 4, and I think the answer is supposed to be 5, right? That's one of those special ones. So you need to compute this, given like a equals 3 and b equals 4. Ask the user for two numbers using input. You better convert them to numbers, right? So that then you can use squaring and square rooting on them. Okay? So take a few minutes to try this. Please help each other. And let me give you this page while you're working. That's as much as I can give you. Okay? Definitely import the math library. So try to get two numbers from the user, and then print out the result of those two numbers squared, and then square root of those, that result. How would you do it? And then in the remaining time, there's one last cool thing I want to show you. Okay, sounds good. Thanks for coming. Didn't even notice that. Nice. See you later. You're gonna have to call input twice, right? Convert both of those things. This is a right triangle, by the way. Take about 30 more seconds, and then I'll do it for you. All right. So let me show you how I might do this. I'll call this hypotenuse or something, dot pi. That's essentially what that calculation gives you, right? The hypotenuse of a right triangle. So I'm importing math for sure. I need to get two numbers from the user, so I'll call it A and B. A equals, B equals, they're both going to be inputs. Input, enter A, colon space. And then I need A to be a number, right? Here's a cute trick. Instead of making a new variable that is the float result, let's just put it into A. I can say, give me the float of whatever the input was. Because input will be replaced with the string that the user types, then I'll turn that into a float immediately. That's pretty neat. That's something you can do. Then we'll get B in the same way, and then I'll print out, or maybe I'll save it in a variable first. Let's calculate A squared plus B squared, the square root of that. So A squared plus B squared, and I want the square root of that, right? So math.square root. Boop. And so if I run this with 3 and 4, in theory, I should see 5. Beautiful. So that's how I might do it. Plenty of ways to do it, though. That's just one. Well, you're going to eventually have to call square root and then square some stuff, right? Are there any questions about how I did that? Is that similar to how you wanted to do it? Even if you didn't get it done in time? All right, so no new assignments today, but one last thing before we go, I want to show you. It will save your life when you're doing Python stuff. It's called Python Tutor. So if you search for that, it's this link, but just search Google for Python Tutor. And let me show you the magic that this thing is. You go to the visualize page, and then you paste code here. The code cannot take input, so you have to hard code values. So let me just steal the first part of this math stuff, like the area one. It can't take input, so you're going to have to hard code things if you want it to, because what it's going to do is show you exactly how this program executes. You put your program in and it doesn't have any input. You click Visualize Execution and watch what happens. It makes a little window that is your program. It has an arrow next to whatever line it's on, and you can watch your program run. If something's going wrong, you can watch exactly how the wrong thing happens and catch it. So I click Next. So I'm on this first line. It just imports the math library. Then it skips all the comments and it goes here. Now I have math. It's like, okay, radius equals 4.5. What happens when that line executes? Click Next. It just made a radius variable with 4.5 in it. See how useful that is? I'll try and zoom in a little bit more. There we go. The next line is area equals math.pi times radius squared. So that'll put this into the area variable. And it's showing you exactly how the variables change and get their first values. You can watch everything happen in this window. And then finally print area. That'll show you the printed output up here. I think you can imagine if you had a longer program and some variables were changing values in a weird way and you didn't understand how and you were getting the wrong answer, you could plop it into Python Tutor, watch it run, and find the first place where something went wrong. Yeah? It's a very, very helpful website, so I encourage you to use it when you're writing your Python programs that I'm going to eventually ask you to write. Okay, so that's Python Tutor. Any questions about that or anything else that we talked about today? All right, that is officially all that I have for us.